Hello everyone, I'm Spandana Gautam from Mechanical Engineering second year regular. I have chosen the topic called Construction and Working Principle of a DC Generator in BEEE. So in this session we'll be able to learn about what is a DC generator and what are the classifications of a DC generator and what are the parts that are present in a DC generator and its working principle and the applications, and last we'll conclude it. So let me explain you about DC generator. It's so simple. Basically, a DC generator is a machine which converts mechanical energy into electrical energy by the principle called Faraday's law. A DC generator operates on the principle of Faraday's law of electromagnetic induction. According to the Faraday's law, whenever a conductor is placed in a fluctuating magnetic field, an EMF is induced in the conductor. And next we'll classify the DC generators. Here are some classifications, and basically DC generator is classified into two types. One is separately excited and self-excited. Here self-excited is again classified into three types: series generator, shunt generator and compound generator. Let me explain you about the parts that are present in a DC generators. Here it is a 3D diagram of a DC generator. Here are the parts. The outermost part, which acts as a shield or a protection layer of a DC generator, is yoke, and these are the brushes. Brushes are the instruments. Those are made of a chromium or a graphite, which holds the field that is generated in the generator. And this is the shaft, and this is the commutator, and the field winding is basically a copper wire is winded through the poles so that it helps in the generating electricity. And here are those poles, field poles, armature conductors, etc. Let us see this 2D representation. This is the yoke, this is the pole and field winding, armature conductors, brushes and terminal box. Terminal box is the thing that all these windings and the connections are connected at one place. This place is known as terminal box. So basically the overall parts of a DC generator are divided into two types. One is starter and the other one is rotor. Starter is a thing that the parts which are static, which doesn't move in a generator, those comes under starter. And the rotor are the parts which rotates, which revolves. These are comes under rotor. And let me explain you about the working principle. We know that this generator is a machine which converts the mechanical energy into electrical energy, and which works on the principle called Faraday's law of electromagnetic induction. When it comes to the working principle, when a conductor is placed in a varying magnetic field, an electromotive force gets induced within the conductor. This induced EMF magnitude is measured using an equation of electromotive force of a generator. If the conductor is provided with a closed path, the induced current will circulate within the closed path. In this generator, field coils will generate electromagnetic field as well as the armature conductors and turns into the field. Therefore, an electromagnetically induced electromotive force EMF will be generated within the armature conductors. This is the basic working principle of a DC generator, and here is the diagrammatic representation of a DC generator, where there will be two poles, north pole and south pole in a generator. Here there will be magnetic flux which is flowing from north pole to south pole. When there is a coil conductor between these poles, and commutator and carbon brushes are present, and this is the axis of rotation. Here we'll get a graph in this way. And let me explain you about the applications of DC generators. Basically, these DC generators are used in alternator as an alternator in a car, and the series DC generator, which we have learnt in the types of or a classification of a DC generator. These series DC generators is used in arc lamps for lightning, stable current generators and boosters. Because of their ability of giving wide range of voltage output, they are generally used for testing purposes in the laboratories. Separately, excited generators operate in a stable condition with any variation in a field excitation. Because of this property, they are used as a supply source of DC motors, whose speeds are to be controlled for various applications. Example, Watt Leonard systems of speed control. And at last, we'll conclude DC generators as we know that DC generators made our life easy, but in fact, that commutators which are used in the DC generator are more complex and that costs us a lot of money. So, a lot of DC generators have been replaced by modified AC generators which are more economical. Thank you.